All right, so in this video we start on chapter 3.1 in the book, which is about functions and function notation. So we are looking at whether or not a particular relation represents a function. That relation could come in the form of a set, a verbal description, so words, a formula, or a graph. And we want to know if that represents a function. We're going to evaluate some functions. We're going to talk briefly about whether a function is what's called one-to-one. We'll do more on that later in this chapter when we talk about inverse functions. And we're going to identify functions using the vertical line test. So a function is just a relation, otherwise known as a rule, that assigns each element of one set, which we're going to call the domain or the inputs, to exactly one element of another set, which we're going to call the range or the outputs. So each input has only, each value of the input has only one output. Okay, so let's write that also. Each input value has only one output. Okay. So we have two relations shown here, and since we're going, it's kind of implied which one's the domain and which one's the range. So our set here, the arrows say if I input 5, I get out 6. So this set here is our domain, this one is our range, and we're getting that because of the way the arrows are. So does this one represent a function? Yes, actually it does. Yes, it's a function because if I input 5, I get out 6, period. There's no other options. I input 7, I get out 6 also. That's okay for just being a function. So my domain here would be 5, 7, 3, and 8, and we probably should put those in ascending order, but we don't care. And then the range 6, 7, and 9. So for the one on the right, however, this one is not going to be a function because 2, if we input 2, there's 2 different values that we could get out. So this one is not a function because the input 2 has 2 outputs, 3 and 5. So our domain, we can still talk about domain though. Our domain would be 2, 3, and -1. And our range would be 3, 5, 6, and 3. So I'd like to think of this kind of our function. It's kind of like a vending machine or a black box. We're feeding it the inputs, which is usually x. And we're going to get out the outputs, which is our f of x, usually y for shorthand, right? It's like a vending machine. A good vending machine, you know, it might have a whole bunch of buttons. You know, let's say it's for soda, and you press the button for a Coke, you expect a Coke to come out, right? And maybe there's 2 or 3 buttons that are for Coke, and so you press any one of those 3 buttons, like here, the 5 or the 7, you're going to get a Coke out. That's fine to get the same output from different inputs, okay? But the first Coke button gives you a Coke. The second Coke button gives you a Coke. But if on the other hand, we had a vending machine where, so they misstocked it and, you know, you hit the Coke button, sometimes you get a Coke, but sometimes you get a Sprite that has 2 different outputs for that one input Coke button, that is not a function. Also not a very good vending machine. Okay. So we've got ordered pairs here. We want to determine if the function is a relation and identify domain and range. So here we have, if the input is 3, are there any other 3s? No. are there any other 5s? No. So the only output for 5 is the 1. The only output for the 3 is 1. The only output for 7 is 1. So my domain, -5 and 7. The range is just 1. But yes, it is a function. All right. Oh, I forgot I had that there, so we'll just say yes. All right, so we have a second example here with a few more points in it. If I have a -5 input, I'm going to get out 0. If I have a 3 input, I'm going to get out -1. If I have a 0, I'm going to get out 0. If I have a 1, I'm going to get out -1. If I have a 3, we say, wait a second. This is the second time 3's come around, and they have 2 different outputs. So this one is not a function because the input of 3 has 2 different outputs. So really you're just looking for repeated x values, repeated inputs, the same value of the input more than once. So our domain on this one, -5, 3, 0, 1. We don't need to list the 3 again. The range, 0, -1, -2. But this one is not a function because of those repeated values of 3. So what rule did we just see demonstrated by the previous examples? Well, just what I said, right? If the inputs repeat, it is not a function. Okay? So if you see 2 in the list of the x's twice, it's not going to be a function, or 3 times, or whatever. Okay? So we cannot have the same input map to 2 different outputs. Not if it's going to be a function. Okay, so what if I give you, words, right? So our domain, our inputs, let's say, is going to be a set of people in a town, like Morrow. And our rule or correspondence, i.e. our function, is going to be, hey, what doctor do you use? And of course, the range or the outputs is all the different doctors that people use, right? So if I pick, Mary, because whatever, and I say, hey, so she's in the town, so she's an input, and I say, what doctor do you use? How many doctors? Is she going to just say one doctor? I don't know, right? Maybe she will. Maybe she only has one doctor. But how many doctors do you go see? You might go see a general practitioner. You might see a dermatologist. You might see an allergist. You might see a cardiologist. You might see a whole slew of doctors. Maybe you only see one. Maybe you see a bunch, right? But in that case, either way, right? That person doesn't have their head. You might have a whole lot of doctors, right? Maybe it's a general practitioner. Maybe if you're a girl, maybe a OBGYN, maybe a whatever allergist will say that, right? So one person may map to, one input may map to more than one doctor, more than one output. So this is not going to be a function. Because a person, we'll say could have, or is likely to have, right, more than one doctor. Okay, so our other example, we have the set of inputs that is a set of bags of chips at the store. Our correspondence or our function is, hey, how much does this bag weigh? And our range, of course, is all the different weights. So the question is this a function, right? So I've got, how much is weighing the bag, we'll say that. So we're going to input a particular bag of chips. How many different values for the weight are going to come out? Well, hopefully only one, right? Unless we go to a different planet or something like that. One bag's going to have one weight because it's not opened, it's at the store, nobody's eaten anything. One bag is going to have one weight to it. So this one will be a function. So each bag input has only one weight, which is the output. Okay, and I went way longer than I meant to, so I apologize for that, but we will stop for a break here.